show you how to solve problems using the ideal gas law. So this is the ideal gas law, PV equals nRT. So first we need to understand what each of these stands for. So P is pressure. And when we use the ideal gas law, we need to use pressure in one of two units, either atmospheres or we can use it in kilopascals. The volume in liters is V. N is the number of moles, and that would just be in moles. And R is the ideal gas constant. So since it's a constant, that means it always stays the same. Now, there's two different values that we'll use depending on the units of pressure. So we'll use 0.0821 if it's in atmospheres, and we'll use 8.31 if it's in kilopascals. And the units of this are a little bit complicated. For 0.0821, the units are liters times atmospheres per mole Kelvin. And for 8.31, it's liters times kPa per mole Kelvin. You don't have to worry too much about those units, but I do want you to know what they are so that if you see them, you're not confused by that. And then T is the temperature, and that always has to be in Kelvin. Okay? So knowing this formula will just save you a little bit of time. Of course, if you have it in your notes, that's great too, but it helps to just know it off the top of your head. All right, so I'm going to show you how we'd solve a problem with this, and then you can try it on the Discovery. So what is the volume of 2.5 moles of gas at a pressure of 0.981 atmospheres and a temperature of 300 Kelvin? All right, so I'm going to start by writing my formula, PV equals nRT. Now, I like to underline all the things that I'm given, and now I'm going to figure out what variable they go with. So I'm going to write all my things over here. I have R, I have T. Okay? So 2.5 moles would be N, because N is the number of moles. 0.981 atmosphere, well, atmospheres are a unit of pressure, so that must be my pressure. I'm trying to find the volume, so that would be, don't know, we'll figure it out. And 300 Kelvin is my temperature. Now you might be like, wait, but what's R? Remember that R is a constant. So I'm going to pick my value of R based on my units of pressure. Since my pressure is in atmospheres, I'll use 0.0821. And then I can substitute in my numbers and solve for my unknown, which is V. So I have 0.981 times V equals 2.5 times 0.0821 and 300. Normally I would put the units in, but I'm going to be honest, I just don't have room on this whiteboard here. Okay, so then I can solve the problem. So I'm going to simplify by multiplying over here. So 2.5 times 0.0821 times 300. So I get 0.981 times V equals 61.575. And then I'm going to divide both sides by 0.981 to isolate volume. And I get that volume is 62.8 liters. Okay, so I want you to try using this formula in the problem and the Discovery. And again, it really does help to list out all the variables and try to figure out what they are before you try to substitute numbers into the equation. It takes a tiny bit longer, but it's usually worth it.